In this problem, we're given some information about theta, and we're asked three different questions, as you can see. Let's go through these questions one at a time. The first question is asking us to find cosine squared of theta based on the given information we have about theta. Well, we know for any arc length theta that this is the true identity. In fact, it's our main identity that we use quite often. And if I know that the sine of theta is 0.7, I can plug that in and solve for cosine squared. You don't need a calculator for this. You can simply work out the arithmetic yourself, and now we have the value of cosine squared of theta. The next two questions you'll see we have are true-false questions. These are a little bit easier if you use a calculator, but I want to show you how I was able to do this problem without a calculator. See if you can follow this. Our first true-false question, or our next question in general, is whether or not the cosine of theta is less than 0.5. Well, we already found out, or excuse me, we were given the fact that the tangent of theta is negative. And I think this will imply that the cosine is negative as well. And if I can prove that the cosine is negative, then wouldn't it be less than 0.5 because any negative number is less than 0.5? Here's how I prove that the cosine of theta is negative. If the tangent is negative and the tangent is sine divided by cosine, then sine divided by cosine is negative. But we know that the sine is a positive number, specifically 0.7. And if 0.7 divided by a number is less than 0 or negative, then that number itself must be negative. Now back to the true-false statement. If the cosine of theta has to be a negative number, then of course it's less than positive 0.5, no matter what it is. And therefore this statement is true. Before I can get to the last question about tangent of theta, I want to introduce a phrase that you maybe haven't heard in a while or never heard. The phrase in magnitude. When we talk about the magnitude of a number, we talk about its absolute value. So in magnitude, -10 is a bigger number than 6. Of course, it's not true if I remove the phrase in magnitude. The statement -10 is greater than 6 is not a true statement, of course. But in magnitude, meaning the distance from 0 or the absolute value, just considering the numbers themselves, not the plus or minus signs, 10 is a bigger number than 6. So in magnitude, we would say -10 is greater than 6. With that general idea in mind, let's approach our last question of whether or not the magnitude of tangent theta, or the absolute value, is greater than 1. To solve this question, I thought about what I already knew about sine squared and cosine squared. Now, one thing I could do if I really wanted to with a calculator here, I'm not going to do this, but what I could do is I could actually radical both sides, find the values of sine and cosine, and then I could compute tangent using those. And ultimately, with a calculator, I could find the value of tangent theta, and then I would know if its absolute value, or magnitude, is bigger than 1. Fair enough. Excuse me, but it's actually possible to do this problem without a calculator. Here's my logic. If sine squared is bigger than cosine squared, excuse me, I said that backwards. If cosine squared is bigger than sine squared, and we knew this from earlier work, then we can say that in magnitude, that the cosine is larger than the sine. Now, of course, we know from this problem that the cosine is negative and the sine is positive, but we're not talking about the plus or minus signs of those. We're talking about the magnitude, or just the positive numbers, if you will. So in magnitude, cosine is larger than sine. Well, that means that the tangent, which is sine divided by cosine, has to be smaller than 1. Why is this? Well, when you look at the fraction sine divided by cosine, if we know that the cosine is larger in magnitude, then the denominator is bigger. And if the sine divided by the cosine is a fraction with a bigger denominator, then, as we always know about when the denominator is bigger, it must be lower than 1. And therefore, in magnitude, the tangent is lower than 1. And if you look at the true-false statement, it's saying that the magnitude or absolute value of tangent theta is greater than 1. We just proved that this isn't true, and therefore the absolute value of the tangent, or the magnitude of the tangent, would have to be less than 1, and hence the original statement is false. And that completes the problem.